together. Then I'll give you time to work on the graphing calculator stuff. So here we have a number of students attending a conference. Depends on the price. Sounds like a max-min problem. Yeah. Doesn't this sound like a question from our last unit? Now, for every $10 increase, only one student less will come. That's pretty good. I'd raise the price way up. But I guess there's only 20 coming to begin with, so you can't raise it up too much before no one would attend. So there we have the equation, 75 and 20. For every $10 increase, we lose one student. Okay? The cost of running the conference is represented by this. Okay? 1,000 plus 75x. So I'm just interpreting that a bit. The $1,000 is probably, you have to pay $1,000 to rent the hall. The thing that is interesting here is, looks like, if I was interpreting this question, it looks like they've created a word problem, but they haven't thought through it exactly. Because if you raise the price 5 times, there's going to be less people that are there. Why would the cost go up for less people being there? I don't know. It kind of feels like something's a little bit off in this question. But for the purpose of learning our graphing calculator, we can do this. What we're going to do is we're going to graph each of these things. What we're going to also have to do is try to figure out a window that's going to be appropriate. So what we're going to do to start with is we're going to start with plugging this equation into y1 and this equation into y2. So here's our graphing calculator. Y equals, clear things out. Let's change this back to a line. I have a few extra calculators if people need them. If you haven't got your own calculator. Okay, so bracket. We're not shading it all in this one. We're just going to graph the lines. So we got 75 plus 10x, 75 plus 10x, and 20 minus x. That's our one graph, and our second graph is going to be 1,000 plus 75x. Now, chances are when we graph this to begin with, we might get nothing showing up or very little showing up. Wow. That line is part of our parabola. Okay? Some of the things that are important to recognize in a question like this, okay? Even though you have a graphing calculator, you have to understand what you're graphing. Do you understand that the first one makes a parabola? Can you see that it will have an x squared in it? Can you understand that the second one with the 75x, that's a line? In fact, it's y equals mx plus b form. If I go back over here, right, and if I think about y equals mx plus b, I can rewrite this as 75x plus 1,000. The 75 would be my slope. The 1,000 would be my y-intercept. If you just imagine graphing that, way up here at 1,000 is my y-intercept. Because my slope is 75, means I would go up 75 over 1. My graph would look like that. Right now, when I'm looking at my graphing calculator, my standard window goes from 10 to 10. There it is. That's the little window that my graphing calculator is showing me. Is it showing me any of that line? No. I also have a parabola, which I don't know what the vertex is. If we completed the square, we could figure out that vertex. But we have some problems here with just our graph. One of the things that we've learned that can help us with our graph is looking at a table of values. Just looking at how x changes. When x is 1, y1, that is the first function that we had, which would have the profit or whatever, and y2 was the cost of the conference. Can you see that all the values are like in the thousands? Okay? And they both seem to be going up as we're going along. So now you have to take this information and think, how should I set up my window so I can see things better? What would I like to look at on my x values? How much would I like to see? What would I like to see on my y values? Okay? Does it make sense to have x go into the negatives in this one? Maybe. Maybe we look at our x's from negative 10 all the way up to 20. But our y, we need to see in the thousands. So let's start with our y max at, how high do they go? Almost go up to 2,000. Let's just see what this looks like if I go up to 2,000 right now. I'm going to change my y scale to 100. That just makes the ticky marks mean every 100. So now when I go to graph, I say, can I see a parabola a little bit better? Yes, I can. Can I see my line a little bit better? Yes. What's that? I can go back to the window. So you have a look at the window as what we set it up as. So you see how your table can help you set up your window? I looked at my table of values, saw what the numbers were like. I think we actually got lucky that it looks so nice on our first try. Usually your first try is like, oh, I still have to go back and fiddle with my window a little bit more. Go back to our graph. Did it drag in there for me? No, it didn't. There we go. So this is a case where it intersects twice. Our parabola intersects with our line at 2 points. And our calculator can find out what each of these two values are quite easily. So if we go back to our calculator, everything that we do to calculate for graphs is second and then the trace button. And which one do you think you're going to use to find out where they cross? Number 5, intersect. Push enter. The nice thing about the intersect thing, you just have to push enter 3 times. 1, first curve, it jumps to the second curve. It asks you to guess, and it will find the closest one. So there it says that at 10 and 1750, that is the first time that they intersect. It means if 10 people come, the cost of the conference and the cost to rent the place, the money you're getting in and the money you have to spend, you'd break even, you'd be happy. Okay? Let's look at the second place where they intersect. So I'm going to go second, calculate number 5 again. Now, it will find this one again because my cursor is closest to that one. So I'm going to move along as fast as I can until I think I'm closer to the other one. I think I'm closer. Now when I push enter, first curve, enter second curve, enter on guess. It finds the other point at -5 and 625. All right. So what do these points mean? Yes, KB. Yeah. What do these points mean? These points mean that if it was -5 for x, what does that mean for our original function? How many people are coming? 25, because x is -5. So 20 minus the -5 would mean 25 people are coming. 75 plus -5, you're only charging $25. Okay? You're only charging $25 to come. And 25 people are coming. And the cost to rent the place when more people come goes down. This is the part I don't really understand. They're providing maybe a lunch, and they're saying if more people come, we'll make it cheaper. So if you do that, then the cost to rent it is $625. And so you would break even at this point because your numbers are exactly the same. Same thing at 10 and 1750. They intersect there. That means the cost and the amount of money coming in, you would break even. Can you see that in between those 2 points that the blue graph is higher, the parabola is higher than the line? The blue graph represents the amount of money that's coming in. The red graph represents the cost to rent the place. Wherever the distance is the biggest in here, like from here to here, that's pretty big. I don't know, does that look like the biggest? Does it look like even more? Here it's, obviously here it's not as much. Wherever that black line would be the biggest, that's where you would make the most amount of money. So you'd have to see where that would be in this case. That would be another question we could solve with these graphs. But right now they're just asked, where do they intersect? And we've talked a little bit about what that means. So that's all we'll do for example 1.